today's video, we are diving into solving radical expressions. These can seem a little bit intimidating at first, but I promise if you just follow these simple steps, you're going to be able to solve all of them, no matter how difficult they may seem. And if you're new to seeing this channel, which hopefully everyone is, considering that we're only having about like 14 viewers per video, go ahead and hit like, hit subscribe, leave a comment, and let us know if you need any homework help. All right, let's dive in. So solving radical equations. So these are the same as any multi-step equation, in that just what you do to one side, you have to do to the other. So, you know, if you have 4 plus x, you're going to subtract the 4 just to get it to the other side. Same thing with multiplication division. You're using the operation that undoes that, so that way you can isolate your variable x or y or z, whatever it is, all by itself, equal sign, and then have a value for it. And in this case, we're just using the property that raising a radical to the power of its index undoes it. So what does that actually mean with the little example? So let's say we wanted to undo, so to speak, the root of x, okay? So what you would do is you would take the index, which is 2, and what we're gonna do is we're gonna actually raise it to the power of that index, and that would end up giving us x. Again, this isn't a perfect example because we're not balancing two sides of an equation. I just wanted to show you in a little kind of micro example, okay? And the reason that this works is, again, this should be reviewed. We already made a video on how to do this. If you want to click that link, it's up in the right-hand corner or down in the description, wherever my producer chooses to put it. If you put this into exponential form, meaning that we are going to multiply by the reciprocal of the index, which would just be 1/2, and then we had that squared. Well, what would that actually be? Well, I would then have x to the power of 1/2 squared. But then that would give me x to the power of 2/2, and that's going to give me x to the 1, which is just x. So you end up with the same thing. So the idea here is when you're solving these radical equations, you put it to the power of the index, and you'll do that for each side, and then you'll be able to simplify by getting rid of that radical symbol, and that way you can actually just kind of manipulate the radicand to only get it by itself, so that way you have a nice x equals or y equals value. Okay, so let's take a look at an easy problem. All right, so here we just have an expression that says, hey, 2 is equal to the square root of x. So again, what I want to do is I want to realize that I'm taking the square root of x. That's implied in this to the power of 1. So just like in our last example, what I'm going to do is I'm going to raise this radical expression to the power of the radicand. So what this is going to look like in my next step is the root of x, technically to the power of 1. Squared. Okay, and again, my squared is still here, but then what is going to happen is I'm also going to do it to the other side, because just like solving any equation, what you do to one side, you have to do to the other. All right, and so what that is going to end up looking like here is that I will then have the, on the inside, I'll have the square root of x to the power of 1. I'm going to turn that into exponential form, so that would end up looking like x to the power of 1/2 squared. And then I can simplify both sides here. I know that 2 squared is going to be 4, is equal to what? X to the power of 2/2. So 4 is equal to x to the power of 1, and then 4 is equal to x. And that should actually make sense, right? Because if we want to check this, does 2 equal the square root of 4? Well, yeah, that checks out. So good. Our math is correct. Our approach is correct. And it really is that simple for every problem that we have. Let's take a look at a median problem. All right, so here we have our median problem where x is equal to the square root of 42 minus x. So I know that there's a little square down here, so I know that I'm going to be raising the square root of 42 minus x to the power of 2. And I'm going to do that to both sides. So I have the root of 42 minus x squared is equal to x quantity squared. Okay, and it's also important to get into a good habit of putting this in parentheses when you square it, because if there's a negative sign and you forget to put those parentheses, you can end up with an incorrect answer. So just always make sure that you're squaring the quantity by putting in parentheses. All right, so I'm going to have x squared here on the left, and on the right, I'm going to have 42 minus x. And now I'm going to simplify. So I'm going to now have x squared, and this is going to become plus x minus 42 equals 0. So I'm going to end up with a trinomial here, and I'm going to have to factor this out. So let's see here. I'm going to have two numbers that are going to equal to negative 42, but then add to plus 1. I'm going to get x minus 6 and x plus 7 is equal to 0. If that step confuses you, Don't worry, we'll be covering that video on how to factor shortly here on the channel. All right, so what this means is that either x minus 6, there we go, x minus 6 equals 0, or x plus 7 equals equal to 0. So x either equals to 6 or x equals to negative 7. Does it equal both? Well, maybe, but you always want to check, because this is where you run into something called extraneous solutions, meaning that technically through factoring and whatnot, you get two answers, possible answers. That's why you always write this or statement, but one of them might not be true. Okay, and I know that's a little confusing, but again, we'll cover that in more detail in a future video. But the point being is that you always, always, always want to check. Okay, so we always need to check our answers. So the question is, when we take this problem up here, does x equal the square root of 42 minus x? We got to check it for both values. So does 6 equal the square root of 42 minus 6? Okay, well, does 6 equal the square root of 36? Does 6 equal 6? Yes. So x equals 6 is a solution. How about negative 7? Does negative 7 equal the square root of 42 minus negative 7? What's going to give me negative 7 is equal to the square root of 42 plus 7. So negative 7 is equal to the root of 49. And does negative 7 equal positive 7? No, it doesn't. So that's an extraneous solution, meaning this solution, x equals 7, is not valid. Meaning that the only answer that we can give here is that x equals 6. And there you have it. Let's take a look at a harder problem. So here we have something that might look a little bit daunting, but again, you just follow the same steps that you have before, and I promise it'll be just as easy to solve as an easy problem. So we have the square root of x minus 2 is equal to the square root of x minus 10. So right off the bat, I'm going to have to square both sides, and you'll see why. You think maybe, oh, should I move the 2 over so that way it's positive 2? You could, but it's actually going to be a lot more complicated. And if you want to see why, I recommend that you try it on your own. But just follow me here, and you'll see why. Like, this is kind of the easier approach. So let's take the square root of x minus 2, and let's square it. And let's make that equal to the root of x minus 10 to the power of 2. Okay, so now what I'm going to end up with is I'm going to end up with the square root of x minus 2 times the square root of x minus 2. And if you're asking why, well, think about what squaring something means. It means that you're multiplying something by itself. Okay, so that's why I have this something, this root of x minus 2, multiplied by itself. So these two right here are equal statements. One of them is just expanded, and then one of them is just written with the square on top. And over here, I have the square root of x minus 10 to the power of 2. So that's just going to give me x minus 10. All right. So now what I'm going to have to do over here is I'm actually going to have to simplify this by foiling this out. And so that way I can write it in its expanded form, and then I can kind of rearrange and combine like terms. That way I can solve for x. So right here, I'm going to have the square root of x times the square root of x. That's going to give me x. And if that's confusing, we went over multiplying radicals in a previous video. Another link, either in the top right corner. I'm not sure which way I'm pointing to, depending on stage left or camera left. But just check the description as well. We'll have that video in there. Either way, the root of x times root of x is x minus what? I'm going to have negative 2 times root x. So it's minus 2 root x. Then I have minus 2 root x. And then I'm going to have negative 2 times negative 2. That's a positive 4. It's equal to x minus 10. All right. So now let's see here. X minus 4 root x plus 4 is equal to x minus 10. Because again, all I did here was I combined these like terms. If I have a negative 2x over here and a negative 2x over here, I'll have a negative 4x right here. Now, we can start simplifying this. So let's combine like terms. Let's go ahead and let's move this negative x over here, and let's move this 4 over here. It doesn't really matter because you're going to end up with the same thing. This is just how my brain kind of likes to balance things out. I like to put the x's on one side and then put the constants on the other. If you have a different way of solving it, that's totally fine. So if I had x, okay, I'll have x minus 4 root x minus x, and I'll have negative 10 minus 4. Okay, so again, I subtracted 4 from this side to get rid of that. I subtracted x from this side to get rid of that, which means I would have this minus x over here and this minus 4 over here. Well, now I have x and then minus x, so that's actually going to be equal to 0. That's going to cancel. Then I'm going to be left with negative 4 root x is equal to negative 16. Okay, so now how can I solve for this? Well, I still have a constant over here, and I have no weird addition or subtraction of any other terms, and I have a constant over here, negative 16. So I can just divide by negative 4. All right, that's going to leave me with the root of x is equal to 4. So now what am I going to do? Well, since I have a radicand, I need to solve for this. I know that my index is 2, so I'm going to raise this side to the power of 2, and I'm going to raise this side to the power of 2. And that's going to give me x is equal to 16. So the question is this a valid solution? Remember, especially in these more complicated problems, you really want to check to make sure that these are not extraneous solutions, but they are actually valid solutions. So if I think that x is equal to 16, let me go ahead and plug it back into this equation to make sure that I get a true statement. So does the root of 16 minus 2 equal the root of 16 minus 10? That's my question. So if I zoom in, I'm going to have the root of 16, that's 4 minus 2. And I'll have the root of 16 minus 10, which is 4. I'll have 2 is equal to 2. Good. So that solution, x equals 16, is valid, and that's my answer. So if you notice that in this video, all of our indexes were 2. We were taking the square root, so we were squaring everything. But keep in mind that even if we had like the fourth root of xy or something like that, all you'd have to do is just raise that to the power of 4. And then you'd get the same answer. Because remember, if I wanted to write this part in exponential form, this would then be the quantity xy to the power of 1 over 4. And I'd basically be taking that to the power of 4. And then just by using my exponential properties, I would then have 4 over 4, which means I would have xy to the power of 1, which would just give me xy. So just by raising something to the power of its index, you're going to be able to get rid of that. Remember, it's not the greatest example because remember, what you do to one side, you have to do to the other. So when it's equation, make sure you're doing it to both sides of it. Okay? So don't forget to like, comment, and subscribe, and leave a comment. Let us know if you have any homework problems that you want us to go over, anything like that. Because again, we are in such a position to where we can offer individualized help due to the low viewer count. But yeah, hopefully some of you found this helpful, and I'll see you guys in the next video. Take it easy.